Good evening, everyone. I hope y'all are doing well, definitely after an exhausting examination period. So, on behalf of the Department of Electrical Engineering, University of Moratuwa, I would like to warmly welcome all of you to today's Electrical Engineering Awareness session. First of all, thank you so much for taking the time to join us in this evening. We know that many of you are currently deciding on your field selection, and that is exactly why we have organized this session. Our goal today is to give you a better idea of what electrical engineering is all about, the opportunities it offers, and what life in the department is really like. Before we hear from our speakers, I would like to spend a minute talking about what you can expect if you choose electrical engineering. Apart from expertise on electrical engineering, our degree offers three specialization pathways for you, which are smart power systems, control and automation engineering, and electrical installations. So, whether you are interested in renewable energy or maybe modern power grids or automation and robotics, maybe designing the electrical systems, there is a specialization that matches your exact interest. So, moving on to the main thing, today we also have three distinguished guests, all proud alumni of our department who have taken very different but equally inspiring career paths. They will be sharing their experiences from university life to research, higher studies, and industry so that by the end of today's session, you will hopefully have a much better understanding of where an electrical engineering degree can take you. We also encourage you to stay with us until the end because we will have a Q&A session where you can ask anything that's on your mind before making one of the biggest decisions of your undergraduate journey. Before we get started, just a quick reminder, if you have any questions during the session, please submit them through the Slido link shared in the Zoom chat. We will collect them throughout the session and answer as many as we can during the Q&A. All right, let's get started. To begin today's session, I would like to introduce our very first speaker, Mrs. Savini Kashmira. Mrs. Savini is a proud graduate of our own department, and after completing her undergraduate studies, she also served as a temporary lecturer in the department, helping guide many students through their academic journey. Today, she is pursuing her PhD at University of Michigan, where her research lies at the exciting intersection of artificial intelligence, compiler technologies, and machine learning systems. Empowering women in this field as much as she can, she has also contributed to cutting-edge AI research through her work with Jaseki Labs. We are delighted to have her with us today to share her journey from being an undergraduate here at UOM to conducting research at one of the world's leading universities. Please join me in giving a very warm welcome to Mrs. Savini Kashmira. Over to you, Mrs. Savini.
Thank you, Hasini, for the nice intro and having me here. So I'll start here. So, hope you can see my screen. So, first of all, congratulations to all of you. So, you have completed your first semester exams. Kudos on it. And now you are at a very important point in your university journey. So you're going to select the department or the field that you will study for the next few years. I know this can feel like a big decision, and honestly, it's a critical decision. It will shape what you study, what kind of projects you do, and what kind of problems that you're going to solve during your undergrad life. I know this kind of but honestly, I do not think field selection should be seen as choosing the fixed path forever. I see it more as choosing a foundation. So, uh, at this point, your question is not just only which department should I choose, it is also what kind of foundation do I want to build? Because the field you choose becomes the base you build for the next few years. And if that foundation is broad and strong, it can help you explore many directions later, even directions you may not be thinking about right now. That is one reason I personally value electrical engineering. Not because electrical engineering is the only good choice, and not because everyone must select electrical engineering, but because, from my experience, electrical engineering gives a very strong and broad foundation. So, to so within that in mind, let me share my own experience first, so you can have an idea about that thing. So I joined the University of Moratuwa in 2018, and after the first semester examinations, just like all of you are doing now, I went through the field selection process and I got selected to electrical engineering. Then I studied electrical engineering curriculum here. So I went through the usual subjects, assignments, labs, experiments, and so on and all of these things. And I come up with being an undergraduate in the department. So, and after coming to my final year, for my final year project, I worked on a robotics and haptics related project. So, you may wonder now, like, what's haptic is. So, haptics is basically the sense of touch. So, as humans, when we touch a surface, we can feel whether it is smooth, rough, soft, hard, or slippery. So, our final year project was about using that idea in a robotics related systems. Specifically for haptic based surface text identification. So we had lot of hardwares and we have to deal with machine learning algorithm and all during our project. So that project helped me understanding something important. So, electrical engineering is not only about one isolated area. As I told you previously, even within this one project, I had to think about sensing signals, then about data, algorithms, and also uh, ML systems, a lot of things. And how a system interact with the real world as well. So you may wonder, like, with an electrical engineering background, can we do a final year project like that, just about robotics and haptic based? You may feel like it's more related to mechanical, mechatronics, or electronics, or so on, like to various fields. But yeah, that was possible in electrical engineering. So, and I will like go with my path a bit more. So then after so this final year project it has selected as the best project for for the 2018 cohort in our department. And so after my undergraduate degree, I worked at the University of Moratuwa in the electrical engineering department as a temporary instructor and then as a temporary lecturer. So that also gave me a kind of different experience because I was still connected to the department, but from the teaching side as well. So it was another experience for me. Then I got selected for the University of Michigan in the USA for my PhD in computer science engineering. Now, at this point, you may wonder, can someone who studied electrical engineering do a CSC PhD? From my experience, yes, it is possible. So in Sri Lanka, we usually talk about departments separately, right? So you know, like we have electrical engineering, computer science and engineering, then electronic and telecommunication engineering, and so on. But in many universities abroad, especially in countries like US and also in many universities in Europe and Australia, these boundaries are more often flexible. You may see departments or scholar like schools named like electrical and computer engineering. So it's just one department, electrical engineering and computer science or similar combinations. So internationally, electrical engineering, computer engineering, electronics, embedded systems are often closely connected within one department. So even in my case, I am doing in my PhD in CSC area after doing electrical engineering as an undergraduate. So when applying, what mattered was not only the exact department name of my undergraduate degree, just electrical engineering? No, it's not. What mattered more was the foundation I had, the projects I had done, the skills I had built, and whether I could learn and work on research problems. So that's what matters most. So now my research direction in PhD is quite different from my final year project as well. I work more on computer systems and architecture related areas, including compilers, and now more onto agentic AI research. So from the outside, it may look like I moved from electrical engineering to robotics and haptics, then to computer science engineering, and now to systems, architecture, compilers, and AI, and so on. But for me, it does not feel like I abandoned one field randomly and jumped into another. So, the foundation I got from electrical engineering helped me explore these various directions. So, it's not, you don't think like it's like going from random paths. If you have the foundation laid in a very efficient and a robust manner, yeah, definitely you can choose whatever direction you like at the moment and it doesn't matter. So, this is why I say field selection is really a foundation choice. So the reason this matters is that we cannot fully predict where technology, industry, or even our own interests will go in next 5 to 10 years, right? So today one area may look very popular. So these days, like AI agents are very popular. But a few years later, another area may become more important. We don't know. So, even personally, what you are interested in now may not be exactly what you want to do after these 3 or 4 years after completing your undergrad degree. So, when you select a field, I think it is useful to ask from yourself, will this field give me a foundation that can adapt with me? So, if the foundation you build is broad and strong, it can give you the confidence and ability to explore many directions later. Sometimes those directions may be things you are already thinking about now, and sometimes they may be paths you have not even considered yet. So, yes, the field selection is important and it's a critical decision, but not because it closes your future into one path. It is important because it decides the foundation you are going to build on. And when you look at electrical engineering as a field, this is why it makes sense. So when you like looking at this slide, you can see like electrical engineering is not just one branch, right? It is more like a tree with many branches. Some people may go toward power and energy, while may go toward robotics, AI, embedded systems, software research, or higher studies. So, the important point is that all these parts can grow from the same foundation. That is why I feel electrical engineering gives a lot room to explore. So and also when like a lot of people hear electrical engineering and immediately think about power lines and then substation, transformers, machines, or wiring, right? So that's what you get into mind when you first heard the word electrical engineering. And yes, the power is a very important part of electrical engineering, and I don't want to make it sound small because power systems are huge, important, and very relevant. But electrical engineering is not only power, it is much broader than that. So think about a phone. Like when we use a phone, we usually think about apps, the camera, the social media messaging, or the software side. But inside that phone, there is a lot of electrical engineering, right? The battery, the screen, the haptics, the camera sensor, the antenna, the processor, and so on all depend on electrical and electronic engineering concepts. So, to me, electrical engineering is about understanding systems. Some systems are very large, like power grids, some are very small, like chips and sensors. Some systems move like motors and robots, and some process information like computers and embedded devices. And some are not directly visible to us, even in the field I'm working on AI and all. And sometimes some people are working on signals moving through a communication network. So that is one thing I really like about electrical engineering. It connects the physical world with the computation world. And once you have that foundation, you can move towards many directions. So you have like here power, robotics, AI, embedded system, software, and lot of related P. So I'm not telling this is from my own story. If I look at my own batch from the electrical engineering department, people went in many directions after starting from that same electrical engineering foundation. So it has been actually, I think, 3 years after since we graduated, and our batch has already taken many different paths. Some are working abroad, while others work remotely for international companies or pursue higher studies, often in field beyond their original specialization. So we have colleagues working on large-scale energy infrastructure projects with L&T in the UAE, and then some work on renewable energy in Denmark and some Europe countries, and industrial automation in Singapore, and AI and machine learning in the US, Europe, and Australia, and lot of countries. And some others are pursuing her master degrees and PhDs in Australia, Canada, US, UK, in areas such as energy, high voltage systems, robotics, computer systems, agentic AI, microarchitecture, and chip design, power electronics, and electrical machines, and in very kind of a broad areas. I mean, like, these all people are from just one graduating batch, right? So the speakers, the other speakers you will hear from the next are further example of these diverse opportunities pursued by graduates from the electrical engineering department. So it's just not only about one path, and from the same electrical engineering batch, people ended up in many different places. And I think that is the most strongest points about electrical engineering. It does not even mean everyone has to do the same job, right? So one person may use that foundation to work on renewable energy, another may use it to build robots, and another may use it to design power systems, and another may use it to move into AI, software, computer systems, and so on. So, what I want to tell is the foundation is the same, but the paths can be very different. And also, when considering about the job market, a lot of students worry about the job market at the moment, right? So some may feel that in Sri Lanka, the job market is saturated, or there may not be enough opportunities in some areas, right? So that concern is understandable, but there are definitely opportunities in Sri Lanka as well, especially if you build the right skills and look for them actively. But at the same time, I think we should look at the bigger picture. Electrical engineering is not limited to one country or one job market, right? So there are global opportunities in many directions, as I told you, in like even from my batch. Power systems are needed everywhere. So renewable energy is growing around the world, and robotics automations becoming important in many industries. And you may know about there is an AI data center called Stargate in UAE. They are having an energy consumption more than the whole Sri Lankan energy consumption. So definitely for those things, they won't be able to get all the engineers that they need to maintain those power grids and all just within the UAE, and they will be hiring international uh, job seekers as well. So that's another opportunity for you to think as well when you do when if you do electrical engineering. So that does not mean opportunities will automatically come just because you selected electrical engineering, but it means, again, I'm telling, it means that foundation is strong to help you complete in many directions, right? So, and this brings me to another important point. The department name is not alone enough. Whatever you select, whatever field you select, you have to build your own path. So, two students can come up from the same field, but one may stay in a narrow path while another one opens much broad opportunities. So, what makes the difference is usually not the name of the degree, it is also curiosity, projects, coding skills, research experience, then learning beyond lectures and talking to seniors and lecturers and looking for the internships, competitions, and opportunity to build things. So that is what makes the foundation better. Electrical engineering, of course, gives you a strong base, but you still have to decide what to use it. So, I would not say just select electrical engineering and everything will happen automatically, but definitely electrical engineering will open you very broad paths instead of just limiting you or just framing you into just one narrow path, right? So that's the main important thing that I need to highlight for you. So actually, this is the probably the main message I want to leave with you. A broad foundation creates flexibility. Your field shapes your base, and what you build on it shapes your path. This is what I think field selection is important. Not because it completely locks your whole future onto that thing, but because it helps decide what kind of foundation you are starting from. So we cannot exactly, again, I'm telling, we cannot tell exactly which technologies will become most important in the next few years. And we also can't know exactly how our own interest will change. So when we are studying when we were doing our electrical engineering undergraduate, like 3 years ago when we were graduating, we didn't think we will be I honestly didn't think that I would be working on uh agentic AI and those kind of things. But as the world is moving, I selected that path because it's having a lot of opportunities. So even our personal own interests can change because the technology is rapidly moving. So, if you have the electrical engineering foundation, definitely you will be able to go on to various paths. It's not only about power or else just power electronics, machines, not only about machine learning, but also chip design and various lot of things. So, in my view, electrical engineering is one of the strongest and broadest foundations you can choose. It gives you technical depth, helps you understand systems, connect hardware and software, and connects the physical world with the computational world. So, when you make your field selection, try not to choose only based on rumors or narrow definitions. Talk to seniors, look at the curriculums, look at the project, look at where graduates go, and think about the type of problems you enjoy solving. Most importantly, do not afraid of a field just because it sounds broad or challenging. A broad field can be a strength because it means there is space for you to find your own path. For me, electrical engineering at Moratuwa was not just a degree. It was the place actually where I learned how to think like an engineer or like a researcher. Like actually, that's the place I got my lot of research skills and other skills as well. So this script helped me work on robotics and it helped me move toward graduate studies and it helps me even now as I work in computer systems and AI related research. So, if you are curious about technology at a deeper level, and if you like problem solving, and also if you want a foundation that can take you into many different directions, I hope you will seriously consider electrical engineering. Not because it is the only good choice, but because it's a strong choice, a broad choice, and a flexible choice. And for many students, it can be the foundation for a very exciting career. So that's what I basically wanted to tell you all. And if you have any questions, I think you can submit in the Slido and like we can answer it at the end of the session. So good luck all of you with your field selection and I hope you will be selecting the most effective and the most effective field that you will be shaping to that rapidly moving future. So thank you all of you and thank you for having me. Over to you, Hasini.
Thank you very much, Mrs. Savini, for sharing your journey with us. I'm sure everyone found it both inspiring and insightful. So, if you all have any questions to direct to Mrs. Savini, please submit them through the Slido link so that at the end of the session we could go through them. Now, let's move on to our second speaker. I'd like to introduce Mr. Anjana Samarakon. Mr. Anjana is currently pursuing his PhD in Department of Electrical and Computer Engineering at University of Illinois Urbana-Champaign. And what piques the most interest is that his research focuses on electrical aircraft propulsion motor design and superconducting motors contributing to the future of sustainable aviation in global level. Before beginning his PhD, he also served as a temporary lecturer in the Department of Electrical Engineering here at the University of Moratuwa. Today, he will be sharing his experiences in higher studies, research, and the many opportunities he got as an alumni of this department. Please join me in welcoming Mr. Anjana Samarakon. Over to you, Mr. Anjana.
Thank you, Hasini. Can everyone hear me? I am using my phone.
Yes, we can hear you, Mr. Anjana.
All right, thank you. Let me share my screen. I hope everyone can see my presentation.
Yes, Mr. Anjana, we can.
All right. Congratulations for finishing a stressful exam at University of Moratuwa, which is harder than A-levels. And I'm glad to be here, talk about my experience at the Department of Electrical Engineering and my experience here, how my education at the Electrical Engineering Department helped me to grow as an researcher, as an engineer. And thank you, Logi, and like all the ESOC people for inviting me to talk to you. Before going into my presentation, let me talk about my journey at EE department. I started in 2014 when I was selecting fields. I had to go like filter out a lot of like myths that my colleagues put into my head. So my first advice to you guys is like do not like talk to the colleagues who do not have any experience in these fields and like base your selection based on their myths. So the first myth I heard when I was in my first semester was People used to think some departments had like a lot of workload, so they thought like those departments are like higher in quality, or they produce something like extraordinary. But that's not the case. There is no comparison that you can draw from the workload. If you like the department, if you like the subject, then it feels like less work, and if you don't like it, it feels a lot of work. And the second thing is, people usually look in the short term. For example, back then, like when the job market was like very high for civil engineering, everybody wanted to do civil engineering, but like within like 4 years, that job market was gone. So don't think in short term. Always think about like the long term, and then the fundamentals that you learn. And thank you for Shihani for your description about this one, because things change so fast. Some departments used to be like the top in the university, but now like it's not, because like things change, like the world is moving so fast. So always think about the fundamentals that we are going to learn and the skill set that you are going to learn. And if I talk my journey at EE department, there are a few things I need to mention which helped me to grow as a researcher. Number one is the staff. And I know like a lot of the staff who taught me are still there in the department. And EE staff is one of the most friendliest and supportive staff that you can find in this university. I remember there was a recent conversation about there was a like a court order that like it asked like lecturers or someone to share their marking schemes or something with the students if the students had a question. And when I heard that, I was surprised, because like this was very normal in EE department. When we were not sure about our grades or our marks, we used to go to the lecturer, knock on the door, and then like they used to give us our like marked paper and the marking scheme. So we go through the marking with the lecturer. So this was pretty normal. So it was like the staff was that friendly, and they were very supportive. And I remember, like we are very shy as first year students to go and talk to lecturers. But in EE department, like we started like having like a very strong bond with the staff, the lecturers from our first year. So that really helped us to grow as research, like grow confidence, and then grow as academics, because confidence and your ability to approach the lecturers and talk about like questions that you have. Sometimes you think like those questions are stupid, but still sometimes those questions may be like very wise. But like we usually do not approach the lecturers and like ask these questions because we are afraid. But like EE had that wonderful environment, like professors were like easily approachable. Even the head of the department, you can like I remember like Professor Nalin was our head of the department, and he used to teach a class, machines class. That's how I got into machines lab, because like I really loved his lecture. And then he was the head of the department at that time. Like anytime, like I used to knock on the door, go used to go talk to him like about like any questions I had like about machines. So that environment is there. And then the other thing is it's more multidisciplinary. um, in EE, you learn thermodynamics, you learn like a little bit about civil engineering, you learn a little bit about CS, and then electronics. So this is like a department where like you learn like most of the multidisciplinary stuff. And then you learn robotics, you learn nuclear. So yeah, E department offers like a strong foundation where after the graduation, it can be like becoming a researcher, it can be doing a PhD, it can be pursuing a job. It gives you a strong foundation, and then you can build on that one, and like it gives you a lot of flexibility. So EE department is like one of the best places for that. And when you like choose fields, do not like narrow your mindset to like just like finding a job right after graduation, because there are a lot of opportunities like if you go abroad, or like even like starting an industry, because now in Sri Lanka we see like they're creating an environment for you to like start your own industry or things like that. So think like in broad terms. And if you know like a lot of like faculty, a lot of like professors in our department, they have their own startups. So that is a culture that you should pursue. So don't like narrow just one job, just don't like focus on CEB. It is just one thing, and there are a lot of opportunities out there. And if you can, and also, as I said, staff is like very supportive. So if you want to like go do a PhD, if you will do something else, they are very supportive. I'm here because of my professors there. I never knew what a first class was when I was in my first semester. In my second semester, one of my friends came and told me like, yeah, I need to get a first class. Like I was like, what's a first class? I didn't even know. So EE department gave me that opportunity to like grow, like learn all these things. And then by the fourth year, I was able to graduate to the first class. And then I had no idea of like doing a PhD. And then it was like Dr. Lindula who told me like, hey, there's this opportunity. I think like given your interest and like your excitement, this will be a good opportunity for you. That's why I'm here. So yeah, EE can like offer you a lot of things. Now, let me talk about machines research that we do here. So this is our machines group, my advisor, and this is our group, and this is our electrical engineering department. It's in Champaign, Illinois, which is 2 hours south of Chicago. The main research that we do here is machine design and mainly electric aircraft propulsion. And also we had some projects related to wind turbines as well. If you have read about electric aircraft propulsion, now there are different types of architectures being pursued. There are like eVTOLs, which are like a drone, which is flying with people. And they're already out there. They're not like commercially available because of the certificates and everything, but they're being produced and like the prototypes are already there, flying in San Francisco. And there are hybrid electric aircraft. If you followed news, General Electric recently tested their first ever, like world's first ever hybrid electric aircraft in Farnborough Airshow in UK. And then in the future, this is a research that we do here, superconducting motors. So by using superconductors instead of traditional copper windings that you see in the motors, you can increase the power density by like many times. This really helps make electric aircraft like commercially feasible in the near future. So these are the things that we pursue in our group. Why am I showing this? So when you design motors, because in EE, we learn generally, like if you talk about a field, in our Sri Lankan mindset, we think that like EE is like they just like do electrical stuff. It can be electric machine, it can be power systems, it can be electrical installation, and civil engineer do his stuff, mechanical engineer do his stuff. But if you actually come into the field of electrical machine design, I know like a lot of other fields are also like that, but especially like machine design, since I do work on this one, I do know about what is involved in electrical machine design. So first, you need to do the electromagnetic design, where I think like from your A levels, you know, the Faraday's law or the Lenz's law. So first, you need to do electromagnetic design. This is like pure electrical engineering that you learn in the classes. But as an electrical engineer, when you design a motor, it is not just electromagnetics. You need to design do the mechanical design, because this is a rotating structure made of a steel or aluminum or like whatever, or titanium sometimes. So you have to do the mechanical design so that it doesn't collapse. And sometimes like you have this like when you like go to very high speeds, especially for aerospace propulsion applications, then this goes through like different types of like mechanical and thermal stresses. So you have to do the mechanical design as well. And you might wonder, like in our traditional mind, okay, so that means like a motor design involves like an electrical engineer, a mechanical engineer, and maybe a thermal engineer, civil engineer. No, it's not like that. It's like electrical engineer has to do everything. And we do it here. So that is why like you need like a strong electrical engineering foundation, and EE, like our EE department provides that one. And also it teaches you thermodynamics and structural engineering and everything. So you learn all these basic skills, and when you come here or like go anywhere, you can um, do all these designs. And then thermal and fluid dynamics. I hope like you had a fluid dynamics class in your first semester. So when you are operating this motor in an airplane or a wind turbine or anywhere, you have to understand like how this fluid flow, like it can be like the coolant, it can be the air, how does it flow through this motor, and like how do you like design so that like it doesn't overheat, right? So all these things you have to do when you are designing a machine. And you also have to do machine testing, because like just building stuff is not fine. I want to like share this like very exciting video with you, because this is something we did in our PhD. So this is a model actually that we built here and then we tested. Let's see if one of these steps are not going well, this is what will happen, right? So these things you learn, and then like you build on this one, you correct this mistake, and then like you do a second iteration. So we had this problem, and then we went to our second iteration. We built this motor, tested, and recently like we published in a conference. So these are the things that you do as an electrical engineer. It is not just like one V equals IR or like just some electrical installation. It's like everything. And then I am coming to my our main research topic, which is aircraft propulsion motor design. So when you design aircraft propulsion motors, you have to understand like how does a flight profile look like? How does the temperature inside the motor like varies? For that one, you also need like aerospace knowledge. So it is not just like you use like your V equals IR. You need to learn about like what is the mission profile of aircraft look like? How long does it last? So things like that. So that is something actually like with a strong foundation, you come here, you read papers, you talk to the experts, and if you have a strong foundation, you can easily learn these things and then apply into a machine design. And then this is a project that we did with NASA. So if you design electrical insulation, which is a material that cover the copper wires from the other structures, you will like face like many issues. So what we have to do is we have to understand how does this insulation perform at like an electric aircraft level. However, then there's a problem. You cannot like build big machines and do that one. So you have to like go in like a small sample levels. So it involves like fundamental research. So this is like a fundamental research that we did here to understand like microscopic level. So this is not, I'm talking about like big machines. So we are like going into the um, like a material level. So this is actually basically material science. You have to like understand a lot of material stuff, because we have to go to the microscopic level, and we use a lot of like microscopes, sometimes like X-ray to like understand like how do these like cracks inside these materials grow. So this is basically material level like fundamental research. So this is something that we recently did with NASA to understand like how do this insulation perform. And then once you understand everything, then you have to design this machine. So all these things that I'm showing here, we are doing as a research group here. So for all of these things, like the foundation was given by the electrical engineering. First, we have to design the stator, which is the motor, like the coil that you see in your regular motors. And it involves like electrical engineering, because you have to understand like how do these like electromagnetic forces work. And also you have to do thermal, which is mechanical. And then when you build the motor, it is electrical, it is thermal, and also structural, which is basically um, saying that like, oh, it's not going to collapse with this like enormous forces that it has to go through. And we are not like giving these jobs to other engineers. So as an electrical engineer, you have to do everything and you learn these things. And then the final thing is, if it is for propulsion, then you have to test these things at altitude condition. So right now we are not putting in an aircraft. So we have to simulate all these altitude conditions inside this big chamber. And then we have to test this motor inside. And it's not only me. We have another like two people from University of Moratuwa Electrical Engineering Department who is working in this group. So we all build this infrastructure to test these machines. So all these like thermal, mechanical, structural, and aerospace things, we are doing ourselves. And also, like, w- when you like need to like test these things, it's not like trivial. So you have to like motor control, which is electronics, CS, and then right now like we are doing test bed development. Why are we doing that one? Because like since we are testing at very high power, high speeds, this can lead to vibration of the building. So what we had to do is we had to dig a new hole, put a new concrete, and then like have a different foundation for this test bed. So it's civil engineering. And then this is the superconducting motor that we are testing. This is cryogenic. Cryogenic is superconductors work at like very low temperatures. So this is like a different physics that we have to work with, because the physics formulas and everything at like cryogenics or like ultra low temperatures is it's a new environment. So this is also a new thing that you have to learn. Well, so why did I present all these things? So the final message I want to give you is, do not like um focus on a narrow path. Just focus on like having a strong foundation, and EE is a best place for you, because I'm not like comparing EE to other departments, but like my experience was that like with EE and the multidisciplinary classes that you take, it gives you a strong foundation for you to like go into other fields and like do multidisciplinary projects. This is very important in this modern era. The reason is with AI and everything, um, an expert in one field is not going to survive, because with the help of AI, you can learn like you're supporting like areas, and then if you can, if a one person can perform multiple tasks with the help of AI, that person is going to replace like many engineers who only know one field. So, given how AI is reshaping this world, I think EE is a wonderful place for you to be. And also, like, I don't know if you are going through the recent publications in our department, E department, and like E department is like focusing a lot on AI as well. Not just AI, how to use AI in electrical engineering and in other things. So this offers you like a wonderful environment to thrive in the future. And yeah, that's all I have to talk about. And I will stay until the end of the this session. So if you have any questions, just feel free to ask me in the chat or at the end of the lecture. Thank you.
Thank you, Mr. Anjana, for that wonderful session. So, as he said, if you have any questions, please submit it through the slider link. Now it's time to the final speaker for this evening, which is Dr. Lilan Karunaratne. Dr. Lilan is also a proud graduate of our department, and he later completed his PhD in electrical engineering at Penn State University, where he carried out research in power system while gaining industry experience as a power system engineer. Today, he works as a senior power system engineer at Tesla, contributing to real world power system challenges at one of the world's leading technology companies. Before pursuing his PhD, he also served as a visiting lecturer here. We are truly happy to have him with us today to share his journey from UOM to Tesla. Please join me giving warm welcome to Dr. Lilan Karunaratne. Over to you, Dr. Lilan.
Hello, everyone. Thank you for having me. Thank you, Logi, for inviting. Just a second, I will share my screen. Can you all see the screen?
Yes, Dr. Lilan, we can.
Cool, cool. So I guess like Miss Savini and Anjana pretty much, covered most of the things that I also wanted to talk about. So, but anyways, like I'll just go through like a couple of things that I want to highlight here. So just a bit about me before starting off. So just like all of you guys, I also started my bachelor's in University of Moratuwa in the electrical engineering department, and definitely I had a really good experience over there. And then the the core discipline that you learned would help me had helped me to diversify into like a lot of specializations. And at the time, uh, so my final year project was sort of focused on the power electronics, and but my passion was in the automation as well. But now that I'm working in the power systems area, so just to give you an example, like how you can whenever you think like you want to shift the field, shift the focus, and how easily you can just get into like different specializations if you build the core engineering discipline, like the fundamentals in the electrical engineering department. So after that, so after we passed out in the 2020, so I for a few months I served as a visiting instructor and then as a lecturer in contract. So afterwards, I joined Pennsylvania State University for my PhD in 2021. And then this year, I defended my PhD and then joined Tesla as a senior power systems engineer. So if I talk about my research during the PhD was focusing on the dynamic stability and controls of converter rich grids. So I'm sure like all of you are aware that we are moving towards more renewable technologies, and then most of the synchronous machine are being replaced by the converter interface generation. So my research was like mainly focused on what type of challenges we had to face, and then how we implement like control solutions, so on and so forth. And then the same experience is being applied in Tesla as well as a power systems engineer. So my work in Tesla is mainly focused on the model development and the product support side. So we have several energy products, mostly the battery energy storages. So one is called the Mega Pack. If you just scroll browse in the internet, so it's a utility scale battery storage. So which is directly connect to the grid for certain applications. So basically, my work is maintaining mathematical models of these mega packs, and then build on it, improve controls, design controls sometimes depending on the application, and then uh, help the internal teams to carry out interconnection studies for the projects uh, that we are consulted on. So those are basically some of the things that I work on in here. So just to give you like a very overall background. Uh, the next thing I want to talk about is like I think so the previous speakers talked more on their experience on the department, and also in their experience on the on the research aspects they are currently working on. But I would rather wanted to just focus on a little bit on the industry right now. So why energy sector is uh, seems to be like one of the most exciting places to be right now. So I'm pretty sure like all of you know the AI data centers and so battery storage, just because I feel like I can there are a lot of other topics, hot topics in the electrical engineering or the energy sector, but I can personally speak to these because I'm more or less like directly involved in all of these things. So the data centers have demanded a huge amount of or huge chunk of power in the grids recently, right? So there is sort of a AI race. So there are a lot of companies in US and all worldwide who are competing to come up with the best model, best LLMs, and best AI tools that they could come up with. So for that, they do a lot of AI training, and then it requires a huge amount of power, so that it induces a lot of stresses on the traditional grids over here, and then it requires a lot of generation. So that's when the battery energy storages came into the picture, and then it actually turned out to be a really good asset in terms of handling some of the challenges pushed through to the grid by the AI data centers and all that. So I don't want to get into like more and more technicals, but I'm just like showing how certain focuses as the focus changes. Like a few years back, the AI data centers is like nothing we have. Sort of something, it's a dormant topic, but right now it's completely redefining the landscape of the energy sector. So all I'm saying, like, so two different things that I got, and then I saw that the previous speaker is also highlighting that the focus continues to change. So the AI data centers may be the hype right now, but a few years down the line, it could be something else. So that is one thing to be keep in your mind. And also the other thing is, uh, having a broader knowledge help you, uh, keep up in the industry. And then if you just have a too narrow knowledge, so you might even, have difficulty to, compete in the job market as well. So, and also the other thing, the Anjana mentioned was that uh, the startup culture. That's something you need to, think about, because the age that you are in right now, so you have a lot of capacity to, experiment on things, and then um, there is a lot of risk you can take at this point. So just go for it. If you have a good idea or a bad idea, just experiment, and then try to do something about it. So that's also one of the key messages I wanted to give, because most of the people that I interact with in here, their mindset is like built in a way that, so they always go after these kind of opportunities. If you just talk to like some graduates in like top universities in the US, so if you ask like why you join the campus, why you join these campuses, and some of them, most of them, their answer would be like, yeah, I want to build a startup. So that's why a lot of people uh, uh, around me sort of encourages us to build the startup. So that's kind of mindset is what we also like need in Sri Lanka right now to uh, help our economy grow better. And the other thing is, uh, so most of the people are worried about this AI thing, how it can replace jobs and all that. So at the same time, I want to say that it does replace some of the jobs, but it also creates opportunities. So as long as you are very good in terms of fundamentals, so let's say like you have some sort of a fundamental knowledge on the electrical engineering. So it's just a matter of applying that into like different applications, and AI is just going to be like a tool, right? So you can just use the AI tool, and then with your fundamental knowledge or the core knowledge you have, you can just overcome whatever the challenges you want. Again, I want to reiterate the message that, so if you come to electrical engineering, it's not just gonna be like electrical stuff. So you can basically diversify into like different areas. So the three of us are like a really good example, because we all graduated from the same degree program. But now Samin is focusing on AI, and Anjan is focusing on machines and drives, and I am focusing on power systems. And then, so you can see like how we can diversify into like different specializations, right? So that is one of the really good things. So it's just like three of the very direct examples, but so there are a lot of other specializations that you can diversify into, like robotics, which is gonna be another hot topic in a few years time, and then communication, AI hardware, that's again a really demanded field in here, and controls, all these things, and biomedical devices, whatnot. So there are a lot of things you can focus on. So the key thing is to build a really good foundation. So that's what I realized also when I go through company interviews and all that. So what they check for is whether you have a solid background. solid fundamentals, and whether you can crack any problem given to you with that fundamental, and then apply whatever the skills that you have to resolve these things. So that's basically what the companies are looking for. And also, if you want to start a startup, or if you want to pursue your career as academia, or as a researcher, so those are the things, like basically the problem solving skill, and then uh, like thinking logically is like what they are looking for, is what it takes to be a good engineer nowadays. Also, I also like uh, give one message here. So how this AI thing has been, in terms, actually it's helping the energy sector right now. So the reason is that, as I mentioned, it demands a unprecedented amount of energy from the grids that we have never, foreseen before. So so that has put a lot of stresses on the grid, as I mentioned, and then there are a lot of challenges are coming up which needs to be solved. So that's why there are a lot of experts are needed in the industry right now to solve these things. So that open up positions as well. And the other thing is like this battery storages. It used to be just um, uh, the hardware device that can store whatever the surplus solar in our houses, and then like feed it, use it as a backup when the power goes out. But now no longer it's just the case, but there are a lot of other applications for the battery storages as well. And you can work on like very exciting controls, very exciting applications. So on the left hand side figure, I just want to give you a very sneak peek of like some of the applications we use the battery storages for in terms of like AI. So like in AI data centers, so they have like clusters of GPUs. They when they train the models, so they turn on and off these clusters of GPUs at once, and then because of which you see like ripples on the grid side, or the it creates a huge amount of stresses on the grid side in terms of like high frequency oscillations. What you see here is that when you're idling, which means like you are not training anything, and so once you have a uh, training data set, training is on, so there's going to be a spike in the power because it consumes a lot of power, and then it can the training load can be like different. This is just an example. And so once the training goes down, and the power can drop to a certain point, and then again this cycle repeats. So this frequency can be like very high. So so all the grid sees from that load, or the AI load, is like this kind of a fluctuation, which is really not good. It uh, stresses the synchronous machines, rotors, and then it induces some stresses on the mechanical parts, which is not really good for the durability of the synchronous machine. So that's when the battery energy storages come into play. So basically, what battery energy storages do is that, so you typically co-locate battery energy storages, or like build them closer to the data centers, so that some of these ripples are absorbed by the battery energy storages, because they have like really fast acting controls. So what happens is that so when the demand is like too high, energy demand is too high, the battery energy storages discharge the power, and then when the demand is too low, battery energy storages absorb the power, so that it so on the grid side you see sort of like a flat line. So that's how that's how the battery energy storage can help uh, smoothen the load in terms of like the AI training. So that's one of the applications we use the battery energy storages in here. So that's just to give you a sneak peek of what we can do and all that. So so the message here is that so when you select the field, most importantly, you should be passionate about it, because then you'll just love the work that you do. Otherwise, you'll be just suffering. So that's one of the key things to keep in mind. And also, if you just think the electrical engineer is just only about the electrical stuff, it's not the case. There are a lot of vast different amount of things that you can specialize into, and so I'm sure like even the other speakers also mentioned that. So the people who's gonna be having the broader knowledge and then ability to use AI tools efficiently to solve problems will be the ones who can compete against the job market and also in the industry in the future years to come. So that is one thing to be keep in mind, and also like focus on the right skill set which is required for certain jobs and for certain companies and all that. For if you're trying to be a researcher, focus on like the right research topics, and so what is more demanding in the future. Just look into the next 5 to 10 years and then decide like what's gonna be the next big thing. What do you think is gonna be the next thing? So and then build the skill set for that, and then that would help you go a long way in this field. So I sort of want to just share that message, and also uh, uh, I'm happy to answer any of the questions you might have in the Q&A session. Yeah, that's all for me. Thank you.
Thank you, Dr. Lilan, for that inspiring session. So now we have come to the final part of our today's program, which is the Q&A session. I hope many of you have already submitted your questions through Sido. We have tried our best to answer as many questions as we can within the available time. And also here in the screen, you can see the QR code, so you can scan it and as well as submit your questions. So, all right, we have received quite a few interesting questions. So, I would first like to go with this. One has asked that their senior friends had told them that electrical engineering job market is kind of difficult. Does that limit their options as they don't want to go overseas yet? So, any of our speakers would like to add their thoughts on that question?
I guess like it's already mentioned that by one of the speakers, right? So it's just not only about the foreign market. You can also have other opportunities available. So basically, you can just work from Sri Lanka and then work for a multinational company overseas. So those are like some of the options you have. Also, like now that the energy sector is like expanding, a lot of companies are expanding as well into like different areas in the world. So there's going to be like a lot of opportunities. It's just not going to be like the Sri Lankan companies that you are looking at. There are a lot of other multinationals, and also like even if there are no branches here at Sri Lanka, you can definitely work from here, work from Sri Lanka to a multinational company. So those are like some of the other options they got.
Thank you so much, Dr. Lilan. Any other speakers would like to add thoughts as well?
Yeah, so actually there are some of my friends from my batch working to international companies remotely from Sri Lanka to mainly some US companies about ML and AI kind of stuff. So yeah, of course you can work on overseas from Sri Lanka and so it's also a good opportunity.
Thank you, Mrs. Savini.
Let me add something to that question. So I think the job market is like mostly related to the country's economy. So I think it's very hard to say like one field is like really good for jobs in like 4 years because the market changes. So it's very difficult to like draw conclusions from the current situation. And the other thing is like if you go to a field that has a really like good job market right now, and if you don't do well, you will not like going to find a job. But like if you go to any department and like you do well, then like you will get a good job. So it's all about like what you like. Thank you.
Thank you so much. So, and now there is some area specific questions like can we expect a strong job market for electrical vehicles in future in Sri Lanka? So what about you?
I think Liran might be the best person to answer that.
Yeah, I mean, we can expect a strong market, but it's hard to say. Like it depends on all the policies that are in place by the government. So how uh, friendly those policies gonna be towards importing electric vehicles. Those are like very key factors that plays a role in this. But let's say like in the ideal scenario, if the government helps these EVs to be imported at a subsidy, like provided subsidies and all that, I think there's a huge potential here. Yeah, I'm just saying that because in US, um, the EVs are like a major thing right now. So a lot of people. I'm not saying like there are no ICE vehicles, internal combustion engine vehicles, but the people are actually moving to the EVs, and people are actually looking into like sustainable solutions, and those are like really cost effective solutions. So people are actually thinking about it, and people actually buying the EVs, and then they see the benefit out of it. So I guess like there's a huge potential in that. Like I mentioned, like there are a lot of factors involved. So yeah.
Thank you, Dr. Leland. So moving on to the next question, they have asked, is there opportunity for electrical graduates to go into biomedical or communication even though they didn't come from biomedical degree or ENTC?
I guess like
Yeah.
Eh,
Oh yeah, Liran, go ahead.
go ahead, Anjana. I was gonna say like Dr. Logi may have a good
Yeah,
answer for that.
because we
Yeah.
don't have like first-hand information,
yeah.
but like it's all fundamental. So even so, if when you talk about like biomedical, it's all about like sensors and like signal processing and things like that, which you learn in EE. So I think like you don't need to have a biomedical degree, but like maybe there are other people like Logi who can like give a better answer.
Thank you so much. And then one asks, what are the things that are covered in control and automation specialization in electrical engineering? I think Dr. Liran would love to answer that.
Uh, I think it's just the fundamentals of the controls, like the linear controls. I think one of the things that uh, was very useful was this linear control techniques, so that you can in the graduate courses you can build on top, and then uh, you can learn more on the nonlinear controls, because the most of the dynamic systems going to be nonlinear, that are you're going to be interacting with. So the core foundation you built, if you're especially planning on going into the automation or just controls side, I would say like the controls courses are like really helpful that we had in our curriculum. So that's one of the things, like just decide the kind of job or a kind of field that you want to go into, and then like try to take the courses that are aligned with those jobs, and then that can help you develop the skill set. So that is one of the major things that you need to research on your own, and then build the awareness. So yeah.
Okay, and also we have few academic related questions. So they have asked whether a good GPA really necessary and whether having a good GPA make them go for a better research abroad or better MSc degree or something like that.
Mm, I think because from my experience, actually, I didn't have a first class. I just missed my first class, but it didn't affect for my PhD. So yeah, GPA does matter, but not. But actually it does matter, but it's not the only thing that matters for you if you're like going for academic path like PhD or masters. It's one thing that matters, but mostly they are looking for the skills and the research skills, problem solving skills, and how much do you have worked on prior project. So it's like project experiences and those kind of things matter a lot more than the GPA. So when I was applying for my PhD, I had two publications, and before before joining to PhD, I was working as a volunteer researcher, and I was doing another project. So that helped me a lot to get into this PhD. So it's not only about GPA, but not a lot of skills matter. So you don't need to worry whether if you don't have a first class. Yeah, that's my experience.
Also related to that, someone had asked that publishing research papers is a must other than a good GPA to go into research abroad.
Uh, I think it's not a must, but if you have publications, it will be a strong because these days, like in US mainly, there are a lot of funding issues, and because of that, there is a decline of like PhD recruiters. So in that case, if you have strong projects that with strong publications, that would be great. But it's not. From my experience, I don't think uh, it's a must. Others can add. Yeah.
Yeah, I want to add something. Since you guys are freshmen in the first semester, I think if you guys ask this question in the last year, we can say like, yeah, it doesn't matter, but like just try for the highest GPA and then like many
Yeah.
publications as possible. If you don't get it, then like, yeah, we can see like what to do. But right now,
Yeah.
like focus on that one.
We don't know whether what will happen in the
Yeah.
future, so it's better to prepare for anything. Yeah.
Thank you so much. And so someone had asked, are job opportunities and salaries for electrical engineers currently low? And will Sri Lanka's 70% renewable energy target by 2030 improve that job market? Quite a specific one.
Um, so I cannot talk about like this like medium term things, but one thing I can say for sure is with this like Iran war and everything, now countries have realized like there are like choke points in the world. Like, so you need to be energy sovereign as a nation. I don't know if you guys have read like China was the least affected because like they have electrified like so much like transportation and everything. And I think Denmark also like least affected. So we don't know about the medium term, but in long term, the world is moving to electrification, transportation, and everything. Because not just because like oil is running out, because of like geopolitics and everything, everybody wants to like generate their own electricity and sovereign like with energy. So Sri Lanka will also come there. We don't know 2030 or later, but long term they will definitely. But the timeline, not sure. But I think yes, it will eventually grow, but we don't know the timeline.
Thank you so much,
Um,
Mr.
I want to add like something here. So in terms of like salaries, if you just focus on like very broad electrical engineering job, yeah, the salary is gonna be a little less. But like I said, there are a lot of specializations. If you like go into robotics, go into AI, so there's a huge potential. You can earn a lot of good money, right? So that's also one thing to be keep in mind. And it's not always about the salary, right? So you got enjoy. You have a passion, right, for things you do. So yeah, that's one another thing. Yeah.
Thank you, Dr. Lilan. And also, one of them have asked, do we need heavy coding? I think they have like meant that do we need a computer science base to go with this degree? So, what's your thoughts on that?
Of course, you don't need heavy coding skills. Even in this AI era, we are not, to be honest, I'm not doing a lot of codings. Actually, AI agents are doing coding, coding agents are doing coding. What do you want to have is like, again, the logical thinking and because AI will do the coding, but AI won't be able to build the entire architecture or the application architecture and the system overview things from the AI. AI can help for that, but definitely first we have to come up with the architectural plan and everything, and then the AI can do the coding part. So heavy coding skill is not required. I'm not telling you don't need to learn coding skills like learn languages. Yeah, you can learn languages, but mainly most of us are not doing coding at the moment. We are just doing the planning and everything from our own, and then coding agents are doing most of the coding stuffs. So I don't think you don't need to have lot of coding skills. Yeah.
Thank you,
And
Mrs.
also,
Sai.
you guys are in the first year, so like I was also not like a big fan of coding, but like when I came to grad school, I had to do coding for like designing machines and optimization. But one thing you will learn is like coding is not a difficult thing. The difficult thing is the logical thinking. I think like all of you guys have that. That's why like you guys are in Moratuwa. So yeah, it's even if you need it, learning is not a hard thing. It's a logical thinking you need.
Okay, thank you. And there is one question towards the corporate sector that can we accept need a management degree to advance in our careers?
Uh, so in my understanding, there are two ways to look at it. So one is it would definitely help if you have a managerial background, if you really want to, climb up in the ladder or the corporate ladder. So you can either do a management degree after the technical programs and then gain some, insights into it, or else you can learn it the hard way. You can just join a company and gain more experience and see how things work and see how your managers, your superiors are, managing the teams, and then how they manage the task, all these things. So so those are like two main things that I observed in the company or the corporate environment. So it's entirely up to you, and also like uh, if I were you, I would be considering uh, the opportunity cost, right? So if you so to get a management job, you have to um, spend some money, spend your time, and then you have to see like how much that cost is gonna help you in your career. So that's also another thing you need to look at. So it's actually uh, completely dependent on each one's situation. It's very hard to say, but some may prefer to go for degrees because it sort of forces you to learn these things, learn these managerial concepts, and some people grasp them by just experiencing them and then reliving those you know uh, the workflows. So yeah, so that's what I have to say. Like there are two ways. Yeah, there are two ways. It's not a must, I would say. I have seen a lot of our senior people, even in Tesla. So they not necessarily have management degrees, but rather they are more technical people. And then they joined the company early in the stages, and then they know all the processes, and then they know how to manage things. And now they are in like really good positions. So yeah.
Thank you, Dr. Lilan. And also, that's a very specific question directed to Dr. Lilan as well. So, could you please share how you joined as a power system engineer at Tesla after the PhD and give insights applying for such a position after the degree or PhD?
Okay, I guess that's a really good question. Like a lot of people are wondering how to land in a job that you like. So for me, definitely doing a PhD helps. So there's this myth or a misnomer that if you do higher studies, you may be narrow focused, and then it's going to be really hard to find a job and all that. It might be the case in Sri Lankan economy if you just consider within the country, but if you consider all the broad opportunities, there are a lot many things that's happening, and then there are a lot of good opportunities are being offered by different companies, different researchers that are going on. So that's one of the things. So if you enroll in a higher study or a advanced degree, master's or a PhD, that would definitely help you. And the other advice I have is, in my case, what helped me the most was like doing an internship. So I was an intern last year at Tesla, and then I was an intern for about 8 months. Uh, so rather than just like participating in the interviews while they're doing the job search, so one way to highlight yourself is just joining the company as an intern, and then you really work and then make an impact so that they can really see what kind of an impact you had in the organization, right? So that would help you, easily land in a full-time position. That's the same thing that happened to me also. Like after the end of, so during the internship, they sort of offered me full-time. So I didn't really have to, just look into full-time positions because it's already secured by the time I finish my internship. So that's one of the major advice that I have to give. Like even any of you, I'm sure like even in your bachelor's degree, you have at the end of the third year, as I remember, there is some time for you to go for the industry and the uh, field visits and all that. Those are like really good experience. Just get the most out of it, and then make connections. So that's gonna be the key thing here. If you want a company, if you land in an interview or something. So the major thing is the connections, right? So it's really important to network wherever possible, and so yeah, and then you can just get the opportunities easily. So that would be my advice.
Thank you so much, Dr. Lidan. And also, we have one question. What job opportunity? Yes, sir.
Sorry, I just want to say like, so even though I advise doing an internship, but it's not a mandatory thing to secure a job. So that's also something I want to reiterate. So there are people, a lot of people other than me, who have not done internships and just joined the really good companies. So that's also an option. It's just gonna be like a little bit difficult to convince the recruiters or the technical people how your work is gonna be impactful. So as long as you can convince that, I think that would be your the other path as well. So, but again, but to make things easier, I would say like go for internships and then get as much as in industry exposure as possible, because that's really, really helpful. Yeah.
Thank you, Dr. Lidan. And the other question is, what job opportunities are available in the maritime sector for an electrical engineer?
If any of you can answer, yeah, I don't have first-hand knowledge about it.
Yeah, the only thing I know about this field is like we have some projects with the Navy that builds superconducting propulsion for ships, but like these are not like immediate job opportunities. So maybe in the future there'll be like many more opportunities if they electrify whole fleet in the world. But like right now, I'm not sure. But like electrical systems are everywhere. Even like it doesn't have to be electric aircraft. Like even right now, if you go to like Boeing 787, like 10 or like 15% of the power is processed through electrical systems. So systems are everywhere. But in Sri Lanka, maybe limited. But if you go to other country, I think like I'm pretty sure there'll be like a lot of opportunities with ship propulsion as well.
Thank you so much, Mr. Anjana. And one has asked, what is the difference between learning embedded system in electrical engineering degree and in the computer science engineering degree, we also have integrated computer engineering specialization. So what is the difference between learning embedded systems here and in the CSE department?
To be honest, I don't have an idea like what the CSAI's curriculum is, but I think if you choose ICE, I think it's ICIs. So when you especially, it will be more focused on embedded software and firmware and IoT, embedded networking, and like computer vision kind of things. But so ICE is generally like the more direct path to an embedded software engineering or a computer engineering, but I think in electrical engineering, it's stronger when embedded systems are being uh, used to control systems, power, and industrial systems. So I think again in electrical, we are covering more broader kind of area in embedded systems, just not focusing on one thing. Yeah, I think any others have idea? That's my opinion.
Uh, I'm sure I don't have much experience on that, but I would agree with Samini because I think like it's gonna be more focused on the computer science related aspects, whereas so what we learn in here could be like broadly applicable to
Any field.
yeah. I mean, yeah, that's all I can say because I don't have much experience on that.
Yeah, thank you. And someone has, how can someone direct their path to AI and machine learning from a power degree?
It's Samini's question.
Yeah, so it's more like I think it's not about a power degree. I would say in electrical, we are not like doing only power, as we all stated. It's a more broader foundation. So if you have the foundation, logical thinking, and the skills you need, definitely you can go into any direction. So I think it's not hard to go into AI and ML stuffs if after learning power and those stuffs because uh we have laid the foundation. So that's what I think.
Thank you so much, Savini. And one has, how do we do the projects? I mean, they have asking as a first year student how they can initiate solo projects or some projects they need like to do. So how can they start it?
Uh yeah, so actually, you can start working on projects on your own, or maybe in when you're doing courses. Again, you have to like there will be course projects, and you can also do your own project. So if you're doing a course project, the course instructor, the lecturer will give you a direction, but it's your own choice to shape you in a way you like matter, and also the way that like to shape it in a more like to being in an efficient and as technology related thing, I would say. So I think it's good to shape your projects in a way you like it and in a way you wanna learn. Like, let's say if you wanna learn about AI, like power related AI, then it's on better to focus on that thing. And yeah, so that's my opinion.
Thank you
I
so
think
much.
with projects, one of the most important thing is like um, focus more on hands-on experience, because this is somewhere like you can learn like using CAD tools or anything. And this is one of the most important things that you can sell for a job or for like PhDs, because at the end of the 4 years, like most of you guys will be like graduating with a second class upper or like a first class, and then like you all have the same qualification. And project is something, if you have like paid much attention and if you have published or if you have done like a good job, this is something that you can sell yourself. I have this skill set, I have done this one. So like focus on that one. As I said, like the EE staff is very supportive. Dr. Logi or anyone, go and talk to them, and then not just for the credit but like do a great job with the project, and they have like good ideas, and also they will be very helpful for you to do a good project and to publish.
Thank you, Mr. Anjana. Yeah.
I want to add a little bit of things. In case like you are working on hardware related projects, or if you decide to work on hardware related projects, I think in my experience, it would help to plan first. Read research papers and then see what's being done and what can be improved and what is your end goal or the final outcome is gonna be. And then in most cases, what we do here is that after the planning stage, we typically come up with the mathematical models or the simulations to actually simulate the whatever the hardware designs, so that it would help instead of just moving to the hardware implementation directly. So we would just focus on the simulations and then see how the controls or the hardware works, and then how it can be improved, and also whether it can operate as intended, because that would help you mitigate a lot of risk. So if you just directly go into the hardware design and then uh, it could be anything, right? It can be a total failure. It can be because you have no idea how it's gonna operate, or like how it's gonna the work. So doing this preliminary simulations and the mathematical modeling is also really good, because uh, that's exactly what we are doing. Because instead of just so as I mentioned, so these mega packs or the battery energy storages. So instead of we just go and directly connect them on the grid, so we do like simulation studies. That's why we need models, right? To see if you just connect this uh, battery energy storage to the grid, so how it can respond to like disturbances, and how it can positively or like negatively impact the grid conditions. So those are the things that you want to foresee, and you don't want to risk all that uh, the things on actual a real asset that could be like really expensive mistakes. So you want to avoid that as well. And then once the simulations have verified that you have a workable model or workable design, and then you will move on to the implementation section or the implementation phase. Then you start off implementing the hardware, and then like after that, you can just test it on the actual or the live systems. So that's what we did during our final projects. Because, like I mentioned, so my project was mostly on the power electronics side. So we sort of created the converter, a grid-tied converter at the time. So that's sort of the steps that we followed at the time. So if it's any help to any of you guys, yeah.
Thank you so much, Dr. Lilan. And so another one had asked, how can we make sure after graduating whether it is good to go for a master's or PhD or go for a job?
Uh, if you wanna give your thoughts.
I think it depends. First, mostly on your choice, because doing a PhD is kind of doing a deep research thing. So if you don't want to do research, then definitely there's no point of. And I'm not telling don't do PhD. Then if you don't have a choice, a strong choice to do a PhD, then it would be hard for you to like do your thing. And I think mostly it depends on the choice. If you want to do a job, and then it's your choice. What are the others think? I don't.
So PhD, of course, huge commitment, right? So maybe it even take more than your bachelor's, right? Sometimes 5 years, sometimes 4 years, depending on how fast you paced in your PhD. Uh, in my case, so why I chose a PhD was it was all sponsored. If you, especially in US, if you wanna go for a funded funded opportunity, mostly it's gonna be on PhDs, not on masters. I'm not saying you cannot find funded masters programs, but it's kind of difficult. Also, having done research would help. And then I sort of like doing research as well. So that was the main reason behind why I went for a PhD. And the other thing is like, I'm just going to be like very honest with you. You need to be like self-motivated because you're going to be like doing a lot of, very narrow focus things for like few years time, right? So there'll be a lot of interesting things along the way, but sort of we are doing a very similar things, um, maybe for like a couple of years. So there are certain places where things can get really, really bored, and you need to have that ability to keep going and also like keep yourself motivated. I think that's the main. That's like one of the skills it takes to do an PhD, and also of course like keeping up good communications with your advisor and uh, somehow make yourself up to date with like what's going on around you. All of these things matter in a PhD. Whereas if you plan on going for industry, I think master's program would also a good alternative as well because you can quickly finish up the masters in about like 2 years, in some cases 1 year, and then join the industry, and then you can gain the experience, industrial exposure, right? So those are like two different things. It's completely depend on your preference, and if you are specifically focused on academia, so PhD would be an ideal choice rather than a master's. But if your focus is on the industry or a corporate job, I would say both plays a good uh, role in terms of building a skill set that's needed for the industry. Uh, Again, like it depends. So if you want, depends between like whether you want to gain more exposure to the industry within the first 5 years, or you want to sort of have a research experience as well before you join in the industry. So it's a uh, thing that you have to weigh on, like depending on your preference.
Thank you so much, Dr. Lilam. So there's one interesting question. So I'd like to take that question before we wrap up. So they ask, what do we care about most, academics, self-projects, or is there anything specific? And also, what do we need to learn in shallow before going in for this electrical engineering degree?
Can you repeat that question?
What should we care about most? It's either academics, self-projects, or is there anything specific? And also they want to know whether what they need to do to need to learn in shallow before going for this electrical engineering degree.
All right, I will have some answers for that. Number one, you don't need to learn anything. He has like great lecturers. All you have to do is like maybe when the classes starts, like in the first 2 weeks, like you might like need to like brush up your A-level knowledge or like first semester like fundamentals. So yeah, do that. And all are equally important. Academics, yes, focus on the academics because you need a good GPA. It can be a second class or whatever. You need a good GPA. Focus on academics. The second thing, projects, as I mentioned, do not like do the projects just for the credits. Do the projects to learn like simulation tools, as Lilam mentioned, learn hardware, and also get the experience, like the problems that you face. Sometimes when we do test motors here, electrical, mechanical, everything goes well. Sometimes like electromechanical, like electromagnetic interference has a problem. So those kind of things you have to learn firsthand. So do the projects like focus on the project, not just for the credits. And the other thing is, if you're going into academia, of course, think about like good publications. E has an excellent staff. If you approach them, if you do a good project, they will guide you how to publish, where to publish, things like that. And then soft skills. Someone had a question about management. Management theories, principles like you can learn at any age by doing a degree, but these skills you cannot like grow after graduate. So talk interact with the professors, grow your confidence because sometimes like in the first year, second year, like don't have the confidence to like answer a question or like ask a question from the professors. But those things you have to grow. So do that. Work with the professors. If you go to an internship, make the connections. Don't be shy, because they will eventually like they will decide like if you get a good job or not. So yeah, focus on all these things. Maybe others have something to input.
Yeah, I 100% agree with Anjana. I think technicals is not the only thing you should be focusing on during the degree. Soft skills are a must. So at any point you're going to be interacting with a lot of other people down the line, whether you are in academia or in a corporate sector. So you need to be able to uh, convey something uh, to anyone, right? So whether irrespective of whether they have uh, a technical background or they are from management background. So irrespective of that, so whatever, let's say like we are coming up with a product, so we should be able to sell it to like anyone, right? So even to the general public. So we shouldn't be talking like technical terms to the general public. They might not understand. So those kind of things you need to excel, and then those are some of the really important skill sets you need to improve. Uh, and also you'll definitely get a chance to do that as well. There'll be like a lot of presentations. Don't be shy, and then uh, try to give the best to those opportunities, and then get the most out of it. Those are like really good learning experiences and learning curves. And what else? I think also like try to be familiarize yourself with like AI tools. So whatever uh, whom say uh, these only gonna be if an engineer in the future. So the the one who's gonna be wanting to hire is a person with the expertise or the ability to work with these tools with the fundamental knowledge. If there are like two people who has the same core knowledge, but one knows how to use the AI tools and one doesn't, obviously the corporate sector would just go for the person with the skill set to handle the AI tools, right? So those are also like some of the cool good things. Like you need to be able to use AI tools as well. So that should be a part of your journey from this point on, because entire landscape will be changed in the future. So you don't want to be left out. So those are like really important things to keep in mind.
Thank you,
Yeah,
Dr.
I also agree with that. Yeah.
So with that, we will conclude our Q&A session, and thank you everyone who submitted the questions. Before we wrap up, I'd like to sincerely thank you, our three speakers, Mrs. Savini Kashmira, Mrs. Anjana Samarakon, and Dr. Lilan Karunaratne, for taking time out of their busy schedules to be with us today and for sharing their experiences with all of us. I'm sure each of your stories has given our first year students a clearer picture of where electrical engineering can take them. And I'd also like to thank you everyone who joined us in this evening. We hope today's session has helped you feel a little more confident about your field selection. One thing we would really like to remember from today is that electrical engineering is not just about lectures and labs. It is about the people you will meet, the experiences you will have, and the opportunities you will create for yourself. Through ESOC, our official student society, you will have the opportunity to organize and participate in a wide range of activities. You will experience flagship events such as the Roundtable Conference, Espire, which is our annual career fair, and also Prakampana, which is our talent show. You might really have seen that iconic light dance and Trickle Patama, which is just exclusively our trickle things. And Viera, our alumni gathering, the department cricket encounter, Freshers Night, which is for you all, and Econ, our international research conference. These are just a few examples of how vibrant life is within our department. Today, you have listened to three completely different journeys. One is a graduate working at the forefront of artificial intelligence research, and another is helping shape the future of electrical aircraft. And another is working on power systems at Tesla. They are all started exactly where you are today, trying to decide which field to choose. Who knows, maybe a few years from now on, one of you will be joining a session like this as a guest speaker, sharing your own journey with another batch of first year students. So, if you are looking for a department that will challenge you, support you, and give you opportunities both inside and outside the lecture halls, we would love to welcome you to the Department of Electrical Engineering. Once again, thank you to our speakers and thank you all of you for joining us. We wish you all the very best with your field selection and we hope to see many of you as part of the electrical engineering family. Have a wonderful evening. Thank you and good night.
Thank you.
Thanks again for having us.
Thank you.
Yeah.